Now we are going to prove some facts about liquid pressure. So the first fact I want to prove is that it has been seen that liquid pressure increases with depth. To prove this, I have an activity for you in which I have a U-shaped manometer, a glass tube which is U-shaped, in which I have added a colored water, and the level of water on both the sides is same. It is attached to a rubber tube, a thistle funnel with stretched rubber band at the mouth of the thistle funnel. Now what I am going to do is, I am going to first, like it is outside, so to start an activity what I do is, I just try to put the thistle funnel into a water container, say at A dash position I just stop the thistle funnel. So what happened, the water exert the pressure on the stretched membrane, which exert the pressure on the air trapped, and due to which that air trapped inside pushes the level of liquid down at one side, and that is side A, and the level of liquid rise at side B. Now what I do is, I just try to move this thistle funnel, say from A dash point to a B dash point, let's say to this point. I just move it to this point. Then I see that the pressure which is exerted now on the trapped air is much more, which in turn is seen that the level of liquid is pushed more and it rises in B. So that means you can see that here initially the level of liquid was same in both the sides. When you put the thistle funnel at position A dash, it pushes definitely it pushes, but the level of liquid go down in A and increases in B. But when you lower the thistle funnel more, then the liquid shifts more. So that means liquid pressure increases with depth. Secondly is that we need to prove, and it is being observed, that liquid pressure remains same in all direction at given depth. Let's say that I have a thistle funnel. To prove this, let's say I have a thistle funnel at point A dash, the same activity. Now when it is at this position, we have seen that the level of liquid at A is here and B, let's say, is till this point. Right. Now what you do is, you try to move the face of thistle funnel this way. That means at the same depth I am just trying to move its face on this side. Then again there is no change in the level. When I try to move the face of the thistle funnel to this side like this, then also the level remains same. So that means at the given point, wherever you face the mouth of the thistle funnel, it doesn't matter, because the level of liquid remains as such, there is no change in the level of the liquid. So actually you can prove that this shows that the liquid pressure remains same in all directions. Third is that liquid pressure depends upon density of liquid. To prove this, I have the same two tubes of same size, and I have a balloon of same size, same everything is attached to the bottom of these two tubes. Now I am going to fill this tube A with water, and I am going to fill this tube B with kerosene. So obviously we have proved that when we put something into a tube, then anything which is stretchable, which is attached here, bulge out. So we see that balloons start bulging out, and when we continue to add water and water, this bulge this much. Now you add same amount of kerosene into it, again it starts bulging, and when the tube is fully filled, we see that the bulging is again there, but the bulging is only this much. So that means here the density part plays a role, as water is more denser than kerosene. So therefore the bulging is more. So that means denser is the substance, more liquid pressure it exerts. Right. So this is how we can prove that it depends upon the density of the liquid. Now we are going to prove that liquid exert pressure on the sides of the container also. So how you can prove that? Suppose I have a tube, I am going to add water into it. Like initially the water is not there, it has a small tube linked with it, small opening, to which I have attached a balloon. Now when I start adding water into it, so when it is filled to an, you can say it is almost filled, or when we start filling it, we see that the balloon also start bulging, and when it gets fully filled, the balloon also bulge like this. So this also, again the bulging is not so much, but still there is a bulging. So that means this also show that the pressure is exerted on the sides also, because you have seen that balloon here is not present at the base, it is present on the side. So when you start filling it, the bulging of balloon also starts, and it starts expanding, and when it is fully filled, it is again a fully expanded balloon. So this again show that liquid exert pressure on the sides also. Now the last what you need to prove is that liquid seeks its own level. So see, I have different shape of tubes, which are glass tubes, which is connected to a horizontal tube. So what I do is, I add a given amount of you can say a liquid into any of it. So let's say I am adding from here. So when I add from here, so I see that when I am adding from this side, but all the tubes get filled. So what happens when, like suppose I add X amount of liquid into it. So when I add X amount of liquid into it, the equal amount you can say first it gets filled, the horizontal tube, and then later these tubes seeks the same level irrespective of the shape. So that means when you are adding something into something means liquid into a different shape of tubes, so they are going, and they are interconnected by an horizontal tube. So that liquid is going to fill the horizontal tube and also these tubes, and the water in these, water or any liquid in these different shaped tubes will be same. They will seek the same level irrespective of the shape of the tubes. So this is what the 5 facts about liquid pressure, that it increase with depth, it is same in all direction at same depth, it depend upon density, the pressure is exerted on the side also, and liquid seeks its own level irrespective of the shape of the container in which you are keeping it, right. So this is what about the liquid pressure and the facts about the liquid pressure.